when we define a structure like this, we can have pictorially the node representation as and this can be a node which is having minimum 2 fields. According to this, we are having 2 fields. One is the data part, and the other is the link part or next part. So next part should point to another node. So this will be the pictorial representation of a node which is being declared using this structure definition. We can store an integer data here, and we can store an address of another node of the same type here. So this forms a single independent node. Such nodes are grouped or linked together to form a linked list. Is it clear now? I'll repeat. We must have a structure definition. It should have a structure tag to name the component of a linked list. We are naming it as node. It should have minimum 2 members. Whatever we define inside structure is called as structure members. It should have minimum 2 members. One should be the information and the other should be capable of storing address, and that address should be the location of another node of the same type. For this reason, we say that each element of a linked list or each node of a linked list is a self-referential structure element or node. So linked list can be called as a collection of self-referential structures. Now after making the declaration of the structure, we should request memory. We have already defined that a linked list is having a dynamic nature. Whenever we need a memory location or memory space, we can make a request for that space and form a node. Then that node can be linked to a list for extending the size of the list. Similarly, we can release the memory which is already being used by a node in a linked list by removing that node. So this is called as the dynamic nature of the linked list. So for extending the size of the linked list, or for the first time we have to create a node and that node represent the linked list. For the first time a linked list will be having only one node. When we add one more node, the linked list will be having 2 nodes, and likewise the size of the list grows. So the steps for node creation is, the first step is structure definition. We have already made that. After that, based on that structure definition, we must request memory space, and for that we will be having a ready-made function or built-in function which is called as memory allocating function, malloc. The syntax for using this malloc function is like this. This is the name of the node. This is the name of the node, and this is the function which returns the requested amount of memory. What is the memory requirement of a structure? We have studied in last semester. The memory requirement of a structure is the size of members of that structure. We have seen that integer needs 2 memory bytes, float needs 4 memory bytes, character needs another 1 memory byte. So we can add the sizes of the members of a structure to find the size of whole structure. So in our case, we have defined 2 members. One is int data, which requires 2 bytes. Another is address. Address may require 2 or 4 bytes. So the total size of the structure node will be the sum of these integer data type and pointer data type. In integer data location, we can store some numbers. In the link part or the next part or pointer part, we can store the address of memory location. That also requires memory space. The total of these two will be the size of structure node. So that size will be returned. This will be an integer value. So in this is a new node is a pointer. So it should have an address location, but malloc is returning an integer value. So we have to convert that integer value into address. This is called as typecasting. So when a function returns a value which is not matched with the variable that is being used for accepting this value, we have to typecast or convert that value into a value which is being matched with the variable which is accepting this value. Therefore, the integer value is being converted into the address of a node, because new node must be an address, a node address. So this is being converted. So this will be a statement in all the programs or algorithms that will be used for or used by using linked list. So you have to by heart this line of text. It's easy. We have to specify a node pointer here. I have used new node. Then we have to typecast using the struct word. For address we are using the star. Then we have to use malloc function. The argument of malloc function is the size of a data type. Here the data type is struct node. So size of struct node will be the summation of space requirement by this node structure. That will be returned. Due to the return value being integer, it has to be converted into node pointer, because the value that's the variable that is being used in the left hand side of this equation is a node pointer. We have to convert that integer value into node pointer using typecasting technique. So this is how a memory is requested. If memory is not available, this function will return null here. If it is available, the memory returns the address of, suppose the size of the structure node is 6 bytes, then from some location 6 bytes of memory will be reserved, and the starting byte will be returned to or stored into this pointing variable. Suppose 5000 is the value returned and the size of the node is structure node is 6 bytes. Then from 5000 to 5005, 5000, 5001, 2, 3, 4, 5, that 6 spaces will be reserved for this node. Is it clear? So after defining the structure, we have to request memory for storing that structure variable. So this is the second step. First we have to define the structure, then we have to request memory using this line of text. The only difference will be the name of the node pointer. This can be varying with different situations. I have used new node here because we are creating a new node. So this will return a null value if memory is not available. If memory is available, an address will be returned to this new node. So the content of this node variable, node pointer, will be an address due to this typecasting technique. Now memory is assigned, then we have to assign values to these fields. We have defined data field and next field. So data field will, suppose we want to store 100 in the new location, we must use new node data equal to, we can use some value here. We can specify some value here. Since data is integer type, we can specify some whole numbers to store. Then the next portion, because this is an independent node, so the next portion should be, next field should be filled with null for the first time. So when we are creating a new node, the data field must be filled with some integer value because we have declared that data type as integer. Then the next portion, next field, should be filled with null value. Now an independent field will be, or independent node will be formed. Likewise, like this, this will be a node with two fields according to our definition. Here we will be storing some value, integer value, and here we must store null for the first time. This will be changed when we take this independent node into a linked list. So keep in mind, for the first time we should store some value here and null value here. Okay. Now link the independent node to the list and change the next values in the nodes to make the node as part of the list. That we will see in the next class. You have to make some changes in the next fields of some nodes in the list as well as the independent node, so that it becomes the part of the previously formed linked list. Hope it is clear to you. I'll repeat. The steps required are: first we have to declare the structure of the node. It should have integer part or a data part, information part, as well as the address part. Then we must request memory for this node. Then the fields must be filled with some value corresponding to the definition, and the next portion, the address portion, must be compulsorily filled with null value. Then this now the independent node is formed. This node can be attached to the linked list using some changes in the next values of other nodes.